All right, we're going to get started. I think if you've been here previously, this is the fourth webinar in our webinar series this year. And the way that we try and do it is we'll do in kind of a generic or informational session on industry-specific information. We've covered, I think, general RF systems and meters, RF system maintenance previously, and then we covered SRT and HEVC compression and video transport and kind of how those things work and how they're interrelated and some common misconceptions in the industry. And then we try and follow that up with an applicable product. So obviously after we just did HEVC and SRT, it makes a lot of sense to jump in with our 4K encoder. So we'll do a quick overview of the 4K encoder through the product flyer, and then we'll jump into the user interface, show you some of the selectability, show you some of the feature set. And then there is a Q&A window available to you, so you can chat in questions at any point in time. And I'll jump in and answer those at the end, or if there's something that's really pertinent as I'm talking because I miss an obvious thing, I'll answer that at the time. So the Encode 4K is a 1RU device, as you can see here, and it is an HEVC/H.265 broadcaster. It doesn't do H.264, it doesn't do MPEG-2. Everything that's coming out from a compression algorithm standpoint is HEVC. It also accepts on the rear input. The only input here is this single HDMI in. There's an IP out for management, there's an IP for broadcasting, and there's an ASI output. But our source is we're looking for a 4K input from, say, like a Bright Sign player or a Vuzix player or something like that. It is important to note here that this is also an HDR device. So if you have some of that HDR, right, high definition video, or the high contrast video resolution, which is inherent in a lot of 4K content, this will support HDR as well. But it will either do that in its pass-through mode, or it can actually, you can configure HDR settings within the device. So I'll jump in and we'll have a quick talk about that. But I did want to make sure to point out when we were starting off here, this is the HDMI input only is what we're looking for, and it is, again, only HEVC on the output. So those are two things to note kind of as I'm going through the user interface and we're having farther discussion on the 4K encoder. So jump into 4K encoder, and the first thing that it's going to tell me is resolution and frame rate, and then how many bits, and then I'm 420 here, so I'm not broadcasting HDR right now. That would need to be 422. So we are doing some compression, and that in the picture quality in man, I'm losing the word. The color quality here is 420 rather than a 422, which you would expect to see for HDR. And then you can also see the bit rate. If you've been on any of our previous webinars, you'll notice this is significantly higher than what we generally talk about when we are talking about video broadcasting. We're normally 4, 8, 10, 12 megabits per second. But for the 4K encoder, right, we're keeping it up here in the mid to high 30s. And that makes sense, right? Because really what 4K is it's telling you there's 4 times as much data in this image or in this video stream than what there is in a standard 1080 high definition image. As you can see, we're all used to thinking of 1080 video, that's 1920 by 1080. What you have here is a 3840 by 2160 image or video if you're getting 4K. And when you do the multiplication on those, there's 4 times as many pixels in a 4K video than there are a standard 1080 video. So the idea that we are significantly higher here on the bitrate bandwidth output makes a lot of sense. When you see the encoder status here in free run, this is just telling me that I don't have like an active source plugged into that. If I were to plug in a Bright Sign player or maybe like a device from CE Labs or some of the other stuff that we have here, one of our own Decode 500s, any of those 4K devices, it would detect that, and you would see this go green and give you a different status update. Right now, it's just telling me, hey, we're not seeing a source, so we're just running. It also is going to give you information on the status page. Again, here's your chroma format with the color differentiation, and there's some stuff in timescale and video PIDs. You can make a bunch of more advanced adjustments to this device than you can to a lot of our previous devices, the Encode 4, the Encode 8, and a lot of that has to do with the SRT broadcasting and some of the settings that you have to do from an SRT standpoint. Same deal with the audio. You can see this information here. There's a little bit fewer adjustments that we want to do when we're looking at the audio side of things. And then the HDMI, it's going to tell you whether it detects HDCP on the incoming source. Obviously, right now, since there's nothing, it's giving you no. And then it's just giving you a lot more information about what you're seeing on the incoming source than what a lot of our previous devices have. And again, a lot of that has had to do with what we're actually intending to broadcast here, with the intention to broadcast 4K and the intention to broadcast with SRT. When we actually go into the setup side of things, this is where we start to take a look at some of the differentiation. So the HEVC profile. We had a couple of issues with some devices that we tested, just for complete transparency, with moving off of the main and the main 10 profile. So if you are broadcasting in something like 422, the full HDR, we have run into some decoders and some devices within the industry that struggle with this profile. So we do make a recommendation when the device goes out that if you're broadcasting to a third-party device, you want to keep it at main or main 10 from your actual HEVC profile standpoint. Bit depth, 10-bit, 8-bit, obviously we understand what that is. And then your RC mode, your compression mode, we're just deciding here whether this is a constant bit rate or it's a variable bit rate. Most of our customers tend to use CBR, right? We're going to define the bit rate and the amount of bandwidth that we're going to utilize with the streaming and keep that as a very static fixed number. But you do also have the ability to drop down here into this variable bit rate. Let's say your source is something like an Apple TV. And then what that's going to allow you to do is when that Apple TV is broadcasting 4K content, when it's doing something that's maybe a graphics that you've created, or maybe you're picking up I'll use a customer application. Maybe you're picking up a Premier League streaming service here in the US and playing that on your Apple TV, and so you've actually got like live 4K sports content going out. And then when the Premier League content's not on, or when the soccer content's not on, or football content, if I have anybody from Europe listening on the podcast, what you run into next is we're going to go to commercial, or we're going to drop away from this program, or the end game show is over, and now we're just no longer broadcasting in 4K, right? Because the only thing that was actually live and being broadcast in 4K is the match itself. You'll want to be in a variable bitrate mode, because then you're going to drop down and you're going to use a significantly less bandwidth in a variable bitrate side of things, because there's just so much. Again, there's 1/4 of the data that we need to send when we're doing 1080p. So the variable bitrate makes some sense if you've got an environment where you're not always going to be broadcasting 4K content. The other thing to note with the bit rate here is, again, different from most of our other encoders, where when you actually go in and define the bit rate, you're going to see this number here for the system bit rate adjust automatically. In basically any encoding that you do, there's the bit rate to actually compress the video itself, the actual content that you're sending, and then there's a bunch of headroom that needs to be allowed within those packets, right? We need to tell the decoder exactly how we've compressed the content. Have we compressed it spatially, temporally? Do we do, what is it, like run length zipping or something like that, where we have a bunch of frames that look the same, so we just zip them all up into one frame and send it as one. So anytime that you're making these adjustments to the bit rate here, you're going to see this system rate automatically adjust, right? because that's just giving the headroom for all of that non-visible data information that also needs to be passed along with the encoding content. And again, this is different than any of the previous encoders that you've seen from us, where if you really look closely at the UI, you'll see where you make the differentiation in the encoder, and you'll look and the output bit rate is different, but we don't show it to you in the same screen. So there's nothing wrong here. There's nothing going on. It's just we're actually visibly giving you the change information here and counting that overhead in the content creation side of things. Other thing to note, as you can see, I'm chroma format main 10, so I can't do my 422 HDR. We do have to be in 422 main 10 in order to be able to do that true 422 HDR broadcasting, and the system is going to make those selections for you. If you are not in the main 10 422, you cannot broadcast with full HDR. So even though we have that as part of the encoder, you still need to select the encoding profile. As I mentioned when we were talking about HDR, if you have content that's already HDR, right, it's already got that high dynamic range, a lot of contrast in it and everything, you can just simply pass that content through as you expect to see here. Or you can disable the HDR if you don't want to do it, or you can have the ability to transfer a bunch of the characteristics that will come along with the HDR content and make some choices on how you want to create that HDR content. Most of the time, what our customers are doing is they already have the 4K content or the HDR content, so this is just being set as pass-through or potentially being turned off entirely. But it is there and available, so if you know what you're doing on the HDR side of things, you can make a bunch of different kind of adjustments and do things that way. Audio, again, pretty straightforward. There's not a lot in audio that's different from HEVC versus H.264, right? You're still using kind of an underlying MPEG compression or potentially using AAC that you see here. The audio is basically the same as what you would have expected to see in all of our other encoders. And then we go to streaming setup. We're going to talk about the output setup first. We use 3 different screens for this. Previous models of the encoder, there was a drop down underneath streaming, and then you were choosing whether or not you wanted to be multicast or unicast. So when we're doing this, the cool part about this is I can have an SRT broadcast enabled. That's the same time I've got a multicast output. So if I've got a source device, whatever that source device happens to be, and it's HDMI is plugged in locally to the encoder, I can broadcast that locally for monitoring of whatever is that we're sending. And then I can also broadcast that using SRT across the internet back to some destination in 60 miles away, 600 miles away. It doesn't really matter. The way that the SRT algorithm works is it's going to attempt to establish that connection and make that packet recovery. I think I mentioned it on the webinar when we did it in early April, talking about SRT and HEVC in general. But when we did our testing for this device, we have the SRT encoder, and then we got a third-party SRT decoder for testing. The encoder was sitting here in the lab, attached to like a Roku box or maybe like a Apple TV or something like that, and it was streaming a movie. And then I live about 60, 65 miles away from the office, as the crow flies. And so that's what we used for the test, is I was just sitting at my house, watching that movie, and able to play everything back nice and easy. So it is kind of cool, and it's a nice feature of the system that you can do this local broadcast so that you can monitor what's going on. And then you can also at the same time have that SRT enabled and be able to send that content all over the place. So just a quick review here in case anybody that's on this is new. When we're creating multicast content, you basically have 2 different types of transport stream that we can utilize. You can make this a UTP URL, or you can make it an RTP URL. The system is going to recognize if you are giving it a format that does not make any sense or is not valid for an output streaming protocol, right? And so the 2 that we're looking at with multicast side of things is you're going to be either accepting UDP or RTP for that transport protocol. And then the broadcast address, this is going to be defined by your installation and by the folks on your network team that are telling you what you have available and what you have open for multicast broadcasting. By default, if you're getting a device from Z-Band, it's going to start at 239.0.0.1 and then progress from there. And then most of the time, we will use port 1234. So what you're actually going to have is a setup that looks like this. And again, the system is going to tell you if you do something incorrect. Like if you delete this colon that separates the last octet of the IP address from the port, you're going to get, hey, we have a problem here. And then as soon as you put that colon back in, everything's good to go. And then, as I mentioned, when we were looking at the flyer of the device, there are 2 ports. I just for like usability purposes, differentiate the output broadcast port from the inbound port. So I'm connected to port 1 right now. That's where all of the management interface is. That's where we're doing the work with this device, which means I'm going to send the multicast output out of port 2. I won't put it on the same port that we're using to access content. And in general, if you're designing IPTV systems, that's kind of how I recommend to do things anyway, because we don't want to have, if there's a misconfiguration in the network, or if for whatever reason there's some sort of broadcast loop, the last thing that we want is that 38 meg or 35 meg of multicast constantly feeding back into the same broadcast port. That's going to cause you some video distortion. You're going to see some pixelization, and just in general, you get a deteriorated video quality when you are looking at feeding multicast back into a broadcast port. It's not a good idea. We don't want to do it. So we're differentiating here and separating and broadcasting on port 2 and managing from port 1. And then in general, that's just like a recommendation that you should do that pretty much all the time when you're setting these things up. And then TTL. TTL is exciting. It's time to live. That's basically how many routers can this stream see before it dies, right? So you broadcast, let's say it's broadcasting from my desktop, it hits the first router within our system, and then the TTL counts down, 4 minus 1 goes to 3. The next router, 3 minus 1 goes to 2. And then obviously at a certain point, we're going to get to 0, and then that's it. No more stream. It dies on the network because the TTL is 0. Again, this is only applicable or only something that you have to deal with in some of these larger enterprise environments where you're broadcasting and maybe we're routing across multiple VLANs, or maybe there's a couple of different network segments on a campus and we're going through a bunch of different router hops. By default, a lot of our devices go out 4 as the setting. Some of them go out with 10 as the setting. We have a government client in Washington, D.C. that does a little bit of point-to-point streaming from basically the National Mall to a building about a mile and a half away. There, the TTL needs to be set to at least 18. Anything other than that, and we don't reach the other end of the network. So this is something when we have clients call and say, hey, everything's set up, everything's configured, everything looks good. I'm still not seeing the streaming. TTL is one of the things that we will check. Again, it is rare, but if you are in a larger enterprise environment or a larger campus, it's definitely possible. Unicast, all of the same things that we talked about apply. I still want to be broadcasting on that output port 2. These are gig ports, so they can handle multiple outbound streams at the same time. And then you have all of these same concept here, UDP or RTP from the broadcast side of things. The difference that you'll notice, right, and this is kind of video broadcasting 101, but we'll review it real quick just because I'm not sure of the technical level of everybody on the line, is this multicast URL you see 239.0.0.1. All multicast exists in this range of 224.0.0.0 through 239.255.255.255. That is where all multicast exists. That's the broadcast range that's set aside specifically for multicast. So what you'll see with the unicast side of things is now we're actually going for a specific device, right? That I want to know where I'm sending this content, where is the receiver, and I want my IP address of that receiver to match specifically within the system. So when you're configuring unicast streaming, like you need to know your destination, and this IP address in here needs to match that destination device, whether that's a PC, whether that's a set-top box, there's a digital signage player, whether it's a server that's then going to transcode that content and make it available on mobile. Doesn't matter. We don't care. Whatever that destination device is, though, that is the IP address that needs to go in here. And the last note on this, again, kind of diving into like streaming 101, is if I enable these two things, I can actually send this content to the same device. And then how I'm going to differentiate that is I'm going to change that port, right? So we can send multiple streams all to the same device. Again, the application there is like a server that's going to take that content and then wrap it up differently so that it's available on mobile devices, phones, that kind of stuff. But when we're sending this content, even though we're sending to the exact same IP address, sending to the exact same IP address, sending the same edge device, the differentiation of that port is always going to allow us to have the server see it as completely unique and completely different streams, even though they're going to the same destination device. And then the last note on that, again, basic streaming stuff, always use even number ports. That is just a rule of thumb. I would love to tell you that I know where that came from, but I've been doing streaming systems since like 2012, 2011, something like that. So the actual origin for that information is long gone. But always use even number ports when you're doing broadcasting, and I'll look it up and send it out as to why exactly that is. But that's one of those bits of information that's in there. It's so old, I don't remember why anymore. And then the SRT side of things, and I would definitely refer you back to last week's webinar if you want a little more information. What we have here is the encoder. So I'm going to set it into caller mode, and then it's going to be looking for the public IP address of our destination device, right? Or if we're doing like a unicast stream to a specific device on network, we could do that as well. But really, one of the things that you're going to need to know from the SRT side of things is if we are setting up streaming over the internet streaming, and that's what SRT is really designed for, right? SRT is secure, reliable transport, and it's meant for limited latency transmissions on high loss networks like the internet or WAN, the wide area networks, that kind of stuff. So we're going to need to know that IP address of whatever our destination is. So I'm just going to do a quick, what is my IP here on my phone, that I can put in something. Yep. All right. So I'll give you the one. This is actually our Z-band office here in Carlisle. This is our IP address. So you would be looking at like a publicly facing IP where it's going to allow the encoder to navigate the internet and look for that specific destination IP, right? And we all know what these things are, that they're all we really see most of the time is underlying you like the domain name google.com or whatever, but all of that is actually underlying their numbers, right? And I'll show you this here. There's an easier way to do that. So when you're looking at this IP address, like you could theoretically have it go and actually look up like a URL or something like that, but it's just going to be easier to show you. What I'm opening now is command prompt, and we have a program running a trace route. And that trace route is just saying, hey, how do I get from my computer to ESPN.com? And so the first thing that command prompt does, or Windows does, is it takes this ESPN.com domain name and resolves it to an IP address. And so anything that you're doing on the internet, whether that's web browsing, whether it is, watching videos from YouTube, Netflix, whatever, even though you're accessing a domain, netflix.com, youtube.com, espn.com, from an underlying standpoint, the data is accessing this IP address that's associated with that domain. And the same principle applies here, where this IP address is what actually allows the stream to navigate the internet and know, hey, this is exactly where I want to go on the public internet side of things. So I know it looks a little funky to just be putting in, hey, this is the IP address of my house or my office or whatever. But that is going to be the key bit of information if we're going to stream over the internet, is we have to know what that IP address is and where exactly that's located. Some of the other adjustments here, latency, bandwidth, that kind of stuff, I tend to not make these adjustments until after we've already established a link. But between the two devices, because the way that this process works, right, is I'm going to enable this. I'm going to put this in caller mode and give it the IP address. And then if there's an SRT device on the other end, as soon as I start broadcasting, this device is going to send out what are basically some discovery packets, right? And then those discovery packets are going to traverse the internet. They're going to go to that IP address on your screen. And then on the other side of things, there's going to be a receive device. And that receive device, if I'm in caller mode, should be in listener mode. If it's in rendezvous mode, then both devices should be in rendezvous mode. But I'm in caller mode. So the receive device should be in listener mode. As soon as the listening device hears those packets, it's going to send back some discovery packets of its own in return. And then that discovery information, the back and forth of those packets, is what actually establishes this link. And then there's other information shared within those discovery packets, right? How much loss did you experience? What was my ping time? What was the round trip that it took? Like, how long did it take me to get from our transmit location to our receive location? And a lot of that information gets shared back and forth between the two devices, and they're going to do some adjustments on, how much video we can send, what we should expect in terms of packet retransmission, all that other kind of fun stuff. So it's really, SRT is very intelligent in how it does that and how it establishes that handshake to be able to kind of know in advance what it expects packet loss to be and how lossy the link is before it even starts sending content. Because what it prevents you from seeing is that kind of Netflix, Hulu thing where you go to access content. Hey, we've tried to access the content. Oh, you don't have enough bit rate, so we're going to buffer, right? And that's they're a little bit different, but you shouldn't see buffering like that with SRT because it's doing that handshake at the beginning and establishing that link. So then the only way that you get into buffering and significant packet loss and stuff like that is if you're in kind of a more dynamic environment and the network changes in the middle of the transmission. There's an increase in packet loss, or something like the more jitter, something gets introduced to degrade that video quality even after that link has been established. But SRT, at least in my experience in working with it, has been really stable, where like once you get that connection and once you get everything up and running, things look good. The rest of it, pretty straightforward stuff. Network setup, this is exactly what you would expect it to be. Port 1 and port 2 are discrete. So port 1, where we do the management, that's the one that has our host name. Right now I have these set for static IP addresses. And then the last thing that's useful that you may want to do is, obviously we can back up this configuration. So for whatever reason, if you're taking this device out on the road, you set it up in the lab, everything looks good, you get out there and, oh man, all the configs are gone. You can just browse that and upload it to the device. I don't expect that to happen. There's no reason that should happen. Maybe you turned it off for 2 weeks. Maybe it was sitting there in the rack and there was an electrical storm and the thing got power cycled and firmware got wiped. There's odd stuff that happens with electronic devices all the time. But you do have the ability to back up that config and save it. Or the other application where we've seen with this is if you have multiple devices, 4, 5, 6 of them, it does make life a lot easier to go through, back up a single configuration, and then upload that. And then the only thing that you're really going through and doing is, adjusting basic network settings. You don't need to go back in and readjust all of the encoder settings, the source settings, the HDR settings. So that's the other application from being able to back this information up here, is you back up one device and then you've kind of got your baseline for any of the additional devices that you need to configure. But that's the overview. It took about a half an hour, which is actually a little longer than I anticipated, of our 4K encoder. So I'm going to vamp here for a little bit on devices that we have that can actually receive these streams. If you would use this time to put any questions that you have in the Q&A, you can absolutely do that. So from an HEVC side of things, the desktop player that comes along with your Z-band IPTV systems, decodes HEVC. So you can watch 4K HEVC content right now on your desktop with a Z-band platform if you've got it. By default, a device like some of our legacy systems that have the Amino H140s, those do not support 4K or HEVC. The Decode 400s do not support 4K or HEVC. Those are 1080 devices. The EP5, the Decode 500 that Z-band offers does support HEVC and 4K. And then my understanding from product development team is you're looking at another set-top box coming down the line, let's call it in the next 12 to 24 months, which will also support HEVC and 4K. And then we'll have some other features on it as well from like an encryption decryption side of things. From a freeware standpoint, let's say, hey, all I really want is this encoder. Then you have options like VLC to play back the content on the desktop. And it is, again, a standards-based platform when you're talking about both HEVC and SRT. SRT is open source, so there's nothing proprietary in SRT from a Z-band standpoint. You can use any HEVC or SRT decoder that's available on the open market. Maybe you already have one, or maybe you want to do some experimentation with things, but we offer SRT decoders, we offer HEVC decoders as a part of our IPTV system. But again, everything that we have talked about up to this point today is standards-based stuff. So you can just kind of get the commercial off-the-shelf equipment and do that as well. So there's a lot of options, and we really hope that you want to add some HEVC to your IPTV system. I don't see any additional Q&A other than Prasanna's contact information. So I will hang out here for a couple of minutes and wait for anything to be put into the chat. And if not, I will shut this down, and we'll talk to you guys again in May. I think next on the schedule is live streaming to the internet, not in an SRT capacity, but more RTMP, RTMPS, Facebook Live, YouTube. I think we're going, the next webinar on the schedule at the end of May is going to be covering those topics in a more industry informational side of things. And then we'll follow that up in June with a webinar on our live streaming, Facebook live streaming encoder. So I will talk to you guys soon. Thank you very much for coming. Bye-bye.